So today we are going to continue with lecture 3 of 3 for this chapter sequences and series. So let's continue with the next part, which is we continuing with the subtopic 3.2, which is the binomial expansion. So the learning outcome for today, the first one is to determine the general term in a binomial expansion a plus b to the power of n is a positive integer, where n is a positive integer. So we are going to continue with the last learning outcome, and then finishing with determine the expansion of 1 plus x all to the power of n for absolute x less than 1, where n is a rational number. Okay, so this is the formula we've learned last week for the binomial expansion with n is a positive value. So we have the T1, T2, T3, and continue with Tn, and the last one is Tn lah. Sorry. So this one in the middle is a T8 R plus 1. Why R plus 1? Because for T1 we start with 0. So for T2 we start with 1. So for R here it should be R plus 1. So the term R plus 1 of the binomial expansion of A plus B to the power of n can be written in the form of T of R plus 1 equal to n choose R, A to the power of n minus R, and B to the power of R. Okay, so we can use this formula to determine the coefficient for a certain term. So for example, for the binomial expansion of a plus b all to the power of 8, the third term, so what is our r here? So our r is equal to, yes, because 3 is equal to r plus 1, so our r is equal to r plus 1 equal to 3, so r equal to 2. Yes, we have to substitute r equal to 2. So it will be 8 choose 2, 8 to the power of 8 minus 2, which is equal to 6, and b to the power of 2. Okay, so the answer will be 28, because 8 choose 2 is 28, and 8 to the power of 6, b to the power of 2. So the sixth term. So how about sixth term? Yes, because r plus 1 equal to 6, so r equal to 5. So 8 choose 5, 8 to the power of 3, b to the power of 5. So the answer will be 56, 8 to the power of 3, b to the power of 5. Let's do some example. So find the coefficient of y to the power of 5 and x to the power of 6 in the expansion of x plus y to the power all to the power of 9. Okay, now we want to find coefficient a certain value. So how to find the solution? So we know that x plus y all to the power of 9, we will have a general form of, yes, because we know that our a equals to x, b equal to y, and n equal to 9. So for y to the power of 5, so what is our y? Yes, b. So when the b to the power of 5, so b to the power of r. So y to the power of r means that, because we want to find the coefficient of y to the power of 5, so r directly equal to 5. So we just need to replace, which term is it when r equal to 5? Yes, the sixth term. So term of 5 plus 1, which is the sixth term, equal to 9 choose 5 multiply with x power of 9 minus 5, and then y to the power of 5. So calculate by using your calculator. So we will get 9 choose 5 equal to 126. So x to the power of 4, y to the power of 5. So everything other than y to the power of 5 will be the coefficient. So what is the coefficient of y to the power of 5? Yes, 126 x to the power of 4. So this is the answer. Okay, so let's continue with x to the power of 6. So when x to the power of 6 means that 9 minus r equal to 6. So r equal to, yes, r equal to 3. So what is the term's number? The term is fourth term. So T3 plus 1, which is T4, equal to 9. Choose 3 and then x to the power of 9 minus 3 and y to the power of 3. So calculate using your calculator. So what we will get is 9 choose 3 equal to 84, x to the power of 6, y to the power of 3. So everything other than x to the power of 6 is the coefficient of x to the power of 6, which is equal to 84, y to the power of 3. So this is the answer. Okay, let's do the next example. Determine the terms independent of x in the following binomial expansion of x plus 1 over x to the power of 8. So we can use the formula of a plus b to the power of n because our n is still a positive value. So we want to find the terms independent of x. What it means by independent of x. So we don't have x in the terms. So it's a constant. So how to do this? First of all, we list out what is our a, b, and n, and then determine which term is it. So x plus 1 over x all to the power of 8. So we have our a equal to x, our b equal to 1 over x, which is equal to x to the power of negative 1. So this one is easier. So we change into the same base, and then n equal to 8. So for x independent means that we don't have any x. So if we substitute into the general formula, what will we have? T of r plus 1 equal to 8 choose r, x to the power of 8 minus r, and x to the power of negative 1 or to the power of r. Okay, because we have x here and x on the other side, what we should do? We have to simplify first by using the rule of indices. So apply your previous knowledge on the indices. So what is the result for this one? So after simplifying, x to the power of 8 minus r with x to the power of negative 1 to the power of r, this part will be negative r. So combining these two x, because it's the same base, what will we get? Yes, we will have x to the power of 8 minus r. So multiply will be plus with negative r. So we will get 8 minus 2r. Okay, so because we want the x independent of x means that the power is equal to, how to get a constant? Yes, x should be to the power of 0 because every value to the power of 0 will be equal to 1. So 8. So for independent of x, which is x to the power of 0, so x to the power of 8 minus 2r equal to x to the power of 0. So 8 minus 2r equal to 0. So r equal to 4. So the term you want to find is actually the fifth term. So the fifth term equal to 8 over 8 choose 4 of x to the power of 0. So what is the result? The coefficient of the term of independent of x, the term independent of x is equal to 70. Got it? Okay, good.